Okay, section 13.3 just introduces a handful of new concentration units. Of course, you already are familiar with molarity, and molarity is probably the most useful concentration unit for a chemist. But there are a number of other ones that exist, and for good reason. In all of these concentration units, we need to be careful to distinguish between solvent, solute, and solution. And for each of these, we're going to kind of find the concentration of the same solution. 12.5 grams of sugar, C12H22O11. So 12.5 grams of sugar dissolved in 100.0 grams of water. And because water has 1 gram per milliliter, this would also be 100 milliliters of water, at least at room temperature. And so we're going to calculate the concentration of this solution in 3 different ways. The first one is percent by mass. And so the percent by mass is the most useful unit for a quick and easy way to describe how to make a solution. It's going to be grams of solute over grams of solution. So that is the solute plus the solvent times 100%. In this case, that would be 12.5 grams over 100 plus 12.5 is 100. 12.5 grams times 100%. Let's figure out what that value would be. And it looks like 11.1%. So you can take this percentage and you could scale it up if you wanted to make, instead of a total of 112.5 grams of this solution, maybe you wanted 50 kilograms of this sugar water solution. Well, that 11.1% sugar by mass is going to be an easy way for you to scale that up. You can just say 11.1 is equal to x over 50 kilograms. Solve for x and you're going to get a mass of sugar to add. Anyway, so that is percent by mass. We don't really use it in other equations, and so it's mostly just useful for describing how to make a solution. This is molality. So molality is different than molarity. And this is moles of solute over kilograms of solvent. Now, 1 kilogram of water is about a liter of water, and so the molality and the molarity are very close to each other for the case of water solutions. For other solvents, molality might differ quite a lot from the molarity. And even for water, as the temperature changes, the density of water changes. And so the molarity is temperature dependent. It will, the molarity will go down as the temperature of water increases, and the molarity will go up as the temperature of water decreases, because hot water expands to a larger volume, cold water contracts to a smaller volume. Molality is independent of the temperature, and so that's one reason why it's useful. And then we'll actually see in the next section where we'll use molality in some equations. So molality is a little bit strange at first, but a very important type of concentration unit. And I will point out that molality gets even more complicated when you have electrolyte solutions that will produce cations and anions, and we'll deal with those in an upcoming section as well. Here we have sugar, which is a non-electrolyte. I'm just going to modify this equation a little bit. Moles of solute particles. Sorry, that's probably the most appropriate way to write this. That's going to eventually encompass that complexity that comes from electrolyte solutions. So let's figure out how many moles of C12H22O11 we have. 12.5 grams. I'm actually going to have to, I can't remember off the top of my head what this is, so we'll calculate it. 12.011 times 12 plus 1.00794 times 22 plus 15.9994 times 11. 342.3 grams. 342.3 grams is 1 mole. So now we can take our 12.5 grams and divide that by the 342. And it looks like we have 36.5 millimoles, or 0.0365 moles. And I'm actually, we're going to want to use that number later. So I'm going to go ahead and write it up here. 0.0365 moles. 0.0365 moles. Barely fits, but we'll need that number later as well. So moles of solute particles, that's 0.0365 moles. We'll divide that by kilograms of solvent. 100 grams of water is 0.100 kilograms. And this is going to give us a molality of 0.365 molal. And we'll represent molality with a lowercase m to distinguish it from molarity that has an uppercase m. So that's the molal concentration. And then last we have mole fraction. And the mole fraction is just the ratio of moles of solute to total moles in the solution. It's represented by this Greek letter chi, which I like to say looks like a pretentious capital X. It's a Greek letter chi, and excuse me, that's going to equal moles of A over the total moles. Here we have our moles of A, but we're going to need to figure out how many moles of water there are. So 100.0 grams of water, 18.015 grams is 1 mole. So let's figure out how many moles of water that is. 100 divided by 18.015. That's going to be 5.55 moles. Let's see. We'll do 5.551 moles. We have a few sig figs to spare. Okay, and then our mole fraction is going to be 0.0365 moles. And let me make this very clear. This is the mole fraction of C12H22O11. It's going to be the moles of sugar divided by the total moles, 0.0365 moles plus 5.551 moles. So let's figure out what that number is. .551. Okay, and that's a 0.00653. Pretty small number. And it is unitless. Now the cool thing about mole fraction is that we can also talk about the mole fraction of the solvent. So we can calculate chi for water. And that's just going to be the moles of water, 5.551 moles, over that same denominator, the total moles, 0.0365 moles plus 5.551 moles. What is the mole fraction of water here? 5.551, and that's going to be 0.9935. If we carry a few more sig figs than we really deserve. Excuse me. A lot of chalk dust here. And, you know, if we add these two together, we're going to get 1 exactly, because adding up the mole fractions of all of the components in a mixture will add up to the whole, or in other words, 1. So we can summarize these concentration units. There they are. Molarity we're already familiar with. Moles of solute over liters of solution. Percent by mass is grams of solute over grams of solution. Molality is moles of solute over kilograms of solvent. And the mole fraction is moles of solute over total moles. That's the solute plus the solvent. And we'll be using these new concentration units as appropriate in future sections.